Good morning to everyone. Today I am going to discuss about Zener diode and Varactor diode. So here, firstly, going with the Zener diode. So here, Zener diode is one of the special diode. It is working in reverse bias condition. Similarly, it is also working in forward bias condition as well as normal diode. Okay. So here, the Zener diode is working in same as that is normal diode. That is nothing but PN junction diode. Okay. Coming to in reverse bias condition, here the Zener diode is going to work or going to operate in reverse bias condition. Okay, and before going to discuss about the Zener diode operation, so here Zener diode is like here also it consists of two type of materials to form the Zener diode, such as one is P-type material, another one is N-type material. So here the Zener diode is having heavily doped materials such as P-type and N-type. Here, due to the doping concentration is high in P side and N side, the depletion layer of this generic is very narrow and it is very thin. Sometimes here there is a rupture in between these P-type and N-type across the junction. Okay, so here one more diode is there, that is nothing but Varactor diode. So here this is the Varactor diode here. Varactor means varying the variable or varicap, or it is a voltage variable capacitance. So generally here it is varying the capacitor across the junction. By giving small impurities across the junction, okay, the capacitance property will be easily variable across the diode by applying the external force. Now we want to go with these diodes. So first one it is Zener diode. As I told you, it is having heavily doped regions. Let us see here. This is a P-type material and this is a N-type material. So those two materials are having a property that is nothing but heavily doped property. So due to this heavily doped P-type and N-type layer, the depletion layer is very narrow. Okay, and there is a rupture of this higher concentration in between these p-type and n-type layer across the junction. Okay, so let us go to the first point here. So here the Zener diode is a silicon p-n junction semiconductor device and which is operated in reverse bias breakdown or reverse bias condition. In forward bias condition, the Zener diode operates similar p-n junction diode. Okay, as I told you in first slide, the Zener diode is operate similar to the PN junction diode, whereas in forward bias condition. And it is only here we can observe the Zener diode is going to operate in reverse bias condition. Okay, why? Before going to this, there is one point that rises here, that is why the PN junction diode is not considered in reverse bias condition. Why? Because by the reverse bias condition applied to the particular PN junction diode, there are minority charge carriers. The minority charge carriers are increases due to increasing the reverse bias voltage. So the process is here increasing the minority charge carriers are collision process. As I told you in previous class, that is the collision process at avalanche breakdown. So by the collision process, the number of minority charge carriers are moving in such a way they are disturbing the outermost orbit electron from the atom. In that way, they are going to increasing order, and then suddenly the current will be increases. So at that situation occurs, that is nothing but is called avalanche breakdown. Okay, that is the procedure here. To do that procedure, there is a high power is dissipated at the junction. So due to that high power dissipated across the junction, it may destructive and the diodes gets damaged. Okay. Okay, here this is the symbol of the particular Zener diode. Okay. Here it is the anode, nothing but it is positive terminal, and this is the cathode, it is the negative terminal. Okay, so let us observe this point here. First point, when the reverse voltage reaches breakdown voltage in normal PN junction diode, the current through the junction and power dissipated at the junction is very high. Such operation is destructive and the diode gets damaged. Okay, by that procedure, by the high power dissipated across the junction due to the increasing the number of charge carriers, that will be gets the device is damaged. So whereas here second point, whereas the diode can be designed with adequate power dissipation capabilities to operate in the breakdown region. Okay, so here in normal PN junction diode, the diode gets damaged. So in order to overcome this problem, we go with another device here, that is nothing but Zener diode. So in this Zener diode, it can be designed with adequate power dissipation capabilities to operate the device in breakdown region. Okay. One such diode is known as Zener diode, and the Zener diode is heavily doped than the ordinary diode. Right. So here we are going to discuss about two types of breakdowns, such as avalanche breakdown and Zener breakdown. So before going to discuss about the reverse bias condition of and VA characteristics of Zener diode, here I am going to discuss about what is meant by avalanche breakdown and what is meant by Zener breakdown. Generally, here the avalanche breakdown, it is the first one. Here it will be occurs when the applied a high reverse voltage across the diode, then the electrons gain some kinetic energy. Okay, as I told you in previous class, by initial velocity is occurred by the reverse bias voltage. If you are increasing the reverse bias voltage, the electrons are gained high kinetic energy. Due to that kinetic energy, they are disturbing the outermost orbit atom, outermost orbits from the atom, and they are disturbing that one. They automatically they dislodge the charge particle, dislodge the charge particles. Nothing but it is a collision process. So due to that collision process, the carrier concentration is going to increase in order. By that increasing process, there is a large amount of current will be suddenly increases. Okay, so let us observe here. The avalanche breakdown occurs when the applied voltage is high reverse voltage across the diode. Then the electrons gain kinetic energy and break the covalent bond, and the free more electrons due to collision, and we have a chain of reaction. Because of this, a large current is produced. At this case, the materials can quickly damage. So to protect the device from this particular situation, or in order to overcome this drawback, we go with another device. That is nothing but here, it is Zener diode, right? And second point, it is a Zener breakdown. When the PN junction are heavily doped, there are direct rupture of covalent bonds takes place because of the strong electric field. So here, the strong electric field is pull the outermost orbit electron from the atom. So due to that process, the charge number of charge carriers are increasing order. That is nothing but it is a rupture occur. Due to that rupture, the covalent bond is breaks and takes place because of the strong electric field. So this electric field will be pull up the charge particle from the outermost orbit, and the new electron hole pair is created and increase the reverse current in reverse bias condition. Okay, our aim here to measure the reverse currents also using Zener diode. So in that way, the reverse bias current is also going to measure. Okay, so next point. The increase in current takes place at a constant value of reverse bias. Typically, it is below 6 volts for heavily doped diodes. Generally, in normal diode, the P and N type materials are lightly doped. If you want to make a condition that is breakdown, then you can apply the larger amount of voltage in reverse bias condition. But here, there is no need such amount of voltage to break down the particular diode because of it is having such as P type and N type materials are heavily doped materials, such as heavily doped material. Okay, so then he says here below these 6 volts, below these 6 volts, the current will be increases because of these layers are heavily doped diodes, heavily doped layers. So as a result here, a heavily doped P and N regions, the depletion becomes very narrow for applied voltage, that is 6 volts or less. If your applied voltage is less than 6 volts, your applied voltage is 6 volts or less than 6 volts, automatically the breakdown will be occurs in Zener diode. Okay, and here the field across the junction is very high, that is 10 power 7 volts per meter, making the condition for suitable for Zener diode. And this is the circuit diagram for the Zener diode is going to working in reverse bias condition. So this is the anode. For that anode, we are making connection with the negative terminal, and here this is the positive terminal, sorry, negative terminal, negative side. Here nothing but it is cathode. For cathode, we are making a connection is positive terminal. Then the diode is going to act as a reverse bias condition. By increasing this voltage, there is a large number of carriers will be increases because of it is heavily doped material, and there is a adequate power is dissipated across this junction. Then automatically we can easily measure the reverse bias current also in reverse bias condition by using Zener diode, right? Next, let us observe the VA characteristics of PN junction and Zener diodes. PN junction diode and Zener diode. Let us see here. This is the PN junction diode and it is the Zener diode. Let us observe the forward bias condition here. As I told you in previous slides, the Zener diode is working same as the normal diode in forward bias condition, whereas the difference is occur in reverse bias condition. So this is the reverse bias region and this is the reverse bias region for Zener diode, and this is the reverse bias region for PN junction diode. Let us observe here, by increasing this reverse voltage, there is a slight amount of current will be available here. That nothing but reverse current. It is nothing but leakage current. If the PN junction is reverse bias condition, there is a minority charge carriers are moving across the junction. Due to that minority charge carrier current, there is a current. Due to the minor charge carrier movement, there is a current is generated. That current here it is called as a reverse current, or it is a leakage current. Further, you can increase this reverse voltage. At particular point, the breakdown will be occurs due to the collision process, nothing but avalanche breakdown. Okay. So if your voltage will be exceeding this level, then breakdown will be occurs. The current will be going like this. Whereas in reverse bias condition in Zener diode, the breakdown will be occurs below this breakdown voltage, and by maintaining constant value, the current will be going like sharply in increasing order. So obviously, we can easily measure the reverse bias current, reverse current in reverse bias condition by using Zener diode. Okay, so here it is a constant Zener voltage. It is the reverse current. Okay, in this reverse bias condition, we can easily measure the current. So coming to the basic structure of this particular PN junction diode and Zener diode. So here the P and N type materials are lightly doped materials. Because of this lightly doping, the depletion layer or the junction of the diode will be wider range. Because of the N-type and P-type materials are lightly doped materials. Whereas in Zener diode, the P-type and N-type materials are heavily doped material. For that, the depletion region will be going to narrow region. Okay. Coming to the VA characteristics of Zener diode. So here the breakdown will be occurs below this 6 volts. But in the case of normal diode, the breakdown will be occurs if your applied voltage is greater than the 6 volts, then only the breakdown will be occurs. Okay. But in the case of Zener diode, the breakdown will be occurs that is less than the 6 volts. Okay. So here let us see the first point. The Zener breakdown occurs that is less than 6 volts, and whereas in normal diode, the breakdown occurs greater than the 6 volts. If the diode is heavily doped, the depletion layer will be thin, and consequently the breakdown occurs at lower reverse voltage, and further the breakdown voltage is sharp. Okay, and here the applications of the Zener diode is voltage regulator. It acts as a voltage regulator, or it is used in various protection circuits and also in voltage limiters. Right? So this is the basic concept of the Zener diode. Generally, it consists of two types of materials such as P-type and N-type materials. Those two types of materials are having a property that is nothing but heavily doped materials. So it is those metals are heavy. The Zener diode is having a heavily doped property compared to normal diode. Due to that heavily doping, the narrow band depletion layer will be occur across the junction. Okay, right. Next one is Varactor diode. Okay, so as I told you, the Varactor means varicap or voltage variable capacitance or a tuning capacitance. So here, this is the symbol of the Varactor diode. This is the terminal anode. This is the cathode. Cathode nothing but negative, anode nothing but positive. Here across the junction, we can add with a small impurity dose at the junction. Here, the transition capacitance will be easily varied. Whenever we can add small impurities across the or diffuse across the junction, then the capacitance property will be easily variable. And here, the Varactor diode is going to work in reverse bias condition. By using this reverse bias condition, how can the capacitance property will be increases and decreases, how it can be variable, we can observe here. Okay, so this is the basic structure here. P-type means it is a positive area, N-type means it is a negative area, because of here majority charged particles are electron such as negatively charged particles. So this negative charge part here act as a plate 1. And here the p type means there are majority charge particles are holes. So here that is the for the majority charge particle here holes, we can say it is a positive charge area. It is the plate 2. For positively charged area, we are making negative terminal. For negative charge area, we are making the positive terminal. Okay. Due to that, there is a dielectric field is then established across this particular junction. If your voltage will be varying, this voltage will be varying, then automatically the capacitance property will be varies across the junction. So let us see these particular points here. The Varactor diode is also called a varicap or tuning or voltage variable capacitance diode. And here with a small impurity dose at its junction which has the useful property that its junction or a transition capacitance is easily varied. Okay. When a large reverse bias is applied across the junction, then we can observe here by using this basic structure. So here the reverse bias voltage is going to variable. Here negative terminal for positively charged area and positive terminal connected to the negatively charged area. Here we can increase this reverse bias voltage, then automatically there is a change in depletion region. Okay, the width of the depletion region will be increases. Okay, if the width of the depletion region increases, the capacitance property is also here it is decreases. Okay, let us see the points here. When a large reverse bias applied across the junction, then the width of the depletion layer is wider. By the decreasing reverse bias voltage, the depletion width W becomes narrow. If this voltage V here, this voltage is V here, that is going to increasing order. If it is in increasing order, the width of the depletion region is wider. Suppose this voltage will be in decreasing order, then automatically the width of the depletion region is decreases. So due to that, here as the capacitance is inversely proportional to the distance between the plates, inversely proportional to the distance between the two plates. Let us see here, the transition capacitance CT is inversely proportional to the width of the depletion region. Suppose by increasing the reverse bias voltage, the width of the depletion region is increases, then automatically the transition capacitance will be decreases. If the applied reverse voltage in decreasing order, then the width of the depletion region is decreases, then the transition capacitance is going to increases. So that's why here the transition capacitance is inversely proportional to the width of the depletion layer. Okay, and here the second point, the transition capacitance CT varies inversely with respect to the voltage also. Inversely, it is varying. It is varies inversely with respect to the voltage. Okay, suppose here the voltage is going to increasing order, then the transition capacitance is decreases. Okay, how it is decreases when we are increasing this voltage, because of by increasing the reverse bias voltage, the depletion region is going to increases. When the depletion region is going to increases, automatically the capacitance property across the junction is reduced or decreases. If the applied voltage is decreases, then the depletion region is going to narrow. So means the junction capacitance is very high across the particular depletion layer. This is a concept of a Varactor diode. Varactor means variable with respect to voltage. If you are increasing the voltage, the depletion region is wider. If the voltage will be decreases, then only the depletion region is narrowing. Okay. Here, let us see the graphical representation of Varactor diode here. The property here it is nothing but. So here, by increasing the reverse bias voltage, by increasing this reverse bias voltage, the capacitance property is going to decreases. Suppose Here, the reverse bias voltage is in decreasing order, then the capacitance property is increases because of there is a change in width of depletion region. Initially, it is here, let us see the points here. Here, increase in reverse bias voltage, then the depletion region is increases and subsequent the capacitance is decreases. At 0 volts across the depletion region or at 0 volts is applied at reverse bias condition, the depletion width is very small and the capacitance is very large, that is approximately 600 picofarads. Okay, suppose here we can apply the zero voltage here, then the depletion region is very narrow. Means the junction capacitance property will be in increasing order like that. Here, see here. Suppose here 0 voltage it is, the capacitance is very high. Okay, that is in terms of 600 picofarads. Suppose the voltage will be going to increasing order, then let us see here. When the reverse bias voltage increases across the junction to the diode, then the capacitance is 30 picofarads. So means as the voltage increases, the capacitance properties decreases from 600 picofarads to 30 picofarads. So this is the basic concept of Varactor diode. Here, the capacitance property is varying by applying the reverse bias voltage or increasing the by reducing the reverse bias voltage. Nothing but he says here it is a voltage variable capacitance. Voltage variable capacitance. If you are changing the voltage, then automatically the variance will be occur across the junction capacitance. Next one. Here, the applications of the Varactor diode. It is used in FM radio and TV receivers, and also AFC circuits. And next one is self-adjustment of bridge circuits. And fourth one is adjustable band pass filters. Adjustable band pass filters. These are the major applications of particular. Here it is a Varactor diode. Okay. This is the basic concept of Zener diode and Varactor diode. Here I was discussing. Thank you.